Hi, everyone. I'm Sandeep. I came long way, fourth floor to here. And thanks for everyone for coming here. I think organizers did a great job in arranging this meet, and it's great to see all the founders of Iceberg right here. Um, so I'll be talking about the optimizing what we are doing in optimizing the Iceberg query performance by doing the kind of heavy lifting of generating the NDVs. Right? So I'm going to start the presentation like at 10,000 feet level, just talk about some of the lakehouse aspects, some of the reInvent launch, and then go deep down into the what is cost-based optimizers, what the Iceberg stats provide, and what are we doing in terms of kind of helping customers to kind of make use of those stats, make the query perform. And I want to start a discussion about like what can we do about Iceberg stats? Can we actually improve the performance stats? We have a lot of ideas. I know the community has a lot of ideas. So just about me, I'm one of the PMs on the Glue Catalog Lake Formation side. Actually, our team is some of the engineers, brains behind this are right here, who help launch Iceberg Stats, Iceberg Optimization, as well as some of the federation as part of the Lakehouse. I love working with the data, I love working with the community. Yeah, great to be here. All right, so Lakehouse. Before that, just how many of you use the Iceberg REST catalog? All right, some of you. How about Iceberg Stats? Okay, we have one person. And then, and what about Iceberg Optimization? All right, one more, one same person. All right, so Lakehouse is the AWS offering that brings everything together, right? So it's kind of, it provides this Iceberg REST API interface. Your data could be in, S3, general purpose bucket, in S3 table buckets, or it could be in the Redshift warehouse in your own specific RMS or Redshift managed storage. Doesn't really matter because you now have the Iceberg REST APIs that you can use, and you can use any of the query engines or your own Spark or other engines to get access to data. So we are really excited about this open API support. And we also kind of extended that. This is some of the still preview version, but kind of providing a single view to the data wherever it is, right? So that's what we call Lakehouse. Is your data could be in actual data lake, in the warehouse, in the federated catalogs. We want to enable it by bringing the best of the Iceberg in the Lakehouse by providing those kind of APIs, where you can use any of the analytical engines, whether it's Redshift, Athena, and start using the best of the Iceberg. So I'll be focusing this talk on the aspects, primarily focusing on the cost-based optimizer, which is what the analytical engines such as Trino or Redshift or Athena uses. And what does it need in terms of Iceberg capability, particularly the NDVs that they need to build the optimized queries, right? So let's go a little bit deeper. I talked about cost-based optimizer, but never really defined it. I think for those who are coming from the database side of the world, this concept has been there for a long time, right? So you have the query, and the cost-based optimizer is an inherent part of any of this engine, and which determines what is the best way to run this query. And it does that by generating multiple query plans, right? And then after generating multiple query plans, it needs to select which is the most efficient query plan to run. And for that, it needs to know it needs to know the statistics behind it, right? To compute the cardinality and to define and to select which is the most cost efficient plan. And there are multiple techniques that is there in the open source engines like Trinos or Spark or Redshift, and many of these techniques boil down to how do you kind of reorder the joins? How do you do filtering earlier so that you can have the rows which are already filtered, and you don't need to kind of join this kind of large billion row tables. Rather, you can join first the table with the lower dimension, right? But how do this CBO succeed without knowing the basic thing, which is the table stats? In the database world, we took it for granted, right? Every table has those kind of things. But now when you come to Iceberg tables, does it have it, right? I think that's the question that we are now asking. Okay, we have the Iceberg. does it do the stats so that my optimizers work? And so let's go and look at the Iceberg table layout, right? We all are familiar with it. You have this Iceberg catalog, which can be your glue catalog, pointing to the reference to your metadata file, which points to your manifest file, which has a list of the manifest manifest list, which has a list of manifest files and contains the data. And each of these layer, right, you have some stats available, right? So manifest list has certain stats about how many row counts, max, mins. Your manifest has bunch of stats, right, which is record count, the nulls, max, min, etc. And these are very important stats, right? Because when the query executes, it looks at these stats and determines, okay, do I need to go and really access that data or not? And if I know these stats, which most of the Iceberg kind of populates in the most of the time, your queries are pretty efficient in terms of execution. But now, if you think about cost-based optimizer, these file-level stats are not sufficient, right? You need table-level stats because you are making the query plan across the multiple tables. And so what is that Iceberg provides in terms of kind of helping us get those table-level stats? So there's this concept, I think the V2 was launched, which is called puffin file, right? So puffin file is is a very simple specification. It is basically a list of blobs of data which is kept outside of the structure that we saw, right? So we saw the structure of metadata manifest and others, but this file, the puffin file, is kept separately because your NDVs and maybe you can in the future add additional statistics can be a large data set, and you don't want to be in those set of manifest files. So it's kept separately, and then you can populate those puffin files. And as long as those puffin files has a way where the NDVs, the number of distinct values, are captured, you can analytical engines can pick it up, right? And the way it picks up is pretty straightforward. Your catalog knows how to go to metadata, and the metadata has the representation of statistics, right? So you go in the statistic, you see this is a statistic file here, and it tells you, okay, this is a file that has this sketch, and in this particular case, the sketch is a theta sketch, which is what the standard the Iceberg supports, and this is where the NDV values are, right? So your Redshift, Athena can just pick it up from there. So it's great in terms of spec, but do this gets populated, right? That's the question we asked. That's the question the customer kept on asking us. And we found that there were not really good writers at that time when we started working on it. The Trino now supports the writing of the NDV file or creation of the puffin file, but there is not a huge lot of writers who build this. So in this case, basically we decided, okay, this is a part where customers can go and kind of generate these puffin files, which means there's kind of heavy lifting, right? You need to look at the changes in the data. You need to kind of build your sketch because that's the compute-intensive ways of generating the stats. You need to populate the puffin stats. You need to kind of populate the metadata references. And then you need to make sure that analytical engines are default integrated so that their queries are optimized. And so that's kind of the heavy lifting. We thought that something that we should do it. And so this was something that we launched as part of the Glue Catalog feature and integrated with the 1P engines and analytical engines like Redshift, Athena. It's available to everyone, right? So it's in the puffin file. So you can have your own engine can grab those NDV stats and use it in your optimizers, right? And then more recently with the Lakehouse, where we are kind of moving towards the catalog level concepts, right? So these are multi-catalog level concepts where you can have the catalogs and have number of tables in it. We extended this concept to go at the catalog level, right? So you don't even need to do it at the table level. You just go and say, for this catalog, I want any of these tables to be optimized. And anytime the new tables get created, we watch for it. And new tables get created or tables get modified, we look for it. We identify changes, and then we generate the stats on it. So we do all those heavy lifting for you and keep it maintained, right? So that's the key piece of it, to keep it maintained. And then there's a default integration with the analytic engines. And we do it for Iceberg, of course. We do it for other file formats as well, right? So and it's as simple as you go to the catalog level and catalog say, I want to just turn on, make manage the table statistics for me. And that's a kind of simple option you have. And you just kind of provide that option, and then don't worry about the kind of doing it at the table level. And what happens as you create a new table, right, is you can go and look at the table, and you'll see that, okay, your statistics are getting created or generated for those tables. For example, in this case, the schedule is auto. When it's generated, when it's created, what are the NDV values for different columns, right? Those are available to you if you want to look at it. But more importantly, they are available to analytical engines, right? So these analytical engines will look at it, they access it, and then they do the real work, which is actually find a query plan, which is the best efficient plan for this. And the question is does that really work, right? So we tried to do some benchmarking on this. And we found that we did it on the industry data sets like TPCDS data sets. And we ran through a bunch of queries and scenarios and all that. And we found that just having this performance stats, basically NDVs, help us improve the query performance by between like 30 to 80%, right? Which is not bad. Like this is someone doing the job of keeping this table maintained and managed, and you get this up to 80% query performance improvement. Why not, right? And this actually is public blog, so you can go and kind of recreate the environment and maybe not standard based, but maybe run it on your queries and see if you get kind of the query performance improvement. We did it on the other engines like Athena as well, and we are seeing like between 30 to 60% improvement on those queries, right? So we are really excited about the kind of results we are seeing and kind of ability to make these make the Iceberg, which works great, but it can work even greater, even performant by having some of these knobs added. And that's where we want to kind of work with the community, right? Like what is that kind of set of optimizations or the set of additional statistics, secondary indexes that could help in improving the queries further, right? Some of the things that we tried out and we are kind of researching this all the time is, okay, what about right now is supporting theta sketches? What about HLS sketches? Can they be more performant? Can they be more? Can we do it even faster with those? What about the additional statistics type, right? So in the database world, the histograms, MCVs are pretty common. What if we build those and add those as part of Iceberg spec? I mean, this requires change to spec because the current spec is only NDV only, right? So we need to kind of improve the spec. What about additional indexes, right? Like how if we can standardize on some of the additional indexes which are common, that will provide us the kind of query efficiency that we are looking for. May not be needed for all the workloads, but for some workloads, the efficiency could be really high. So we want to see if the community has kind of appetite for kind of improving that and work with you guys on this. The other aspect is we think that the table statistics in general are, in a sense, table stakes, right? In the database world, we assume that it is there, right? But in the data lake world, as you can see from this room, like only kind of few persons know about it, and not many. I would think that not many have those stats on their tables. And there was this question about kind of differentiation and all that, right? And we have seen some vendors kind of putting their stats in their own proprietary ways, which is not available to others. So we want to ensure that stats are open, they are very cost effective. Over the period of time, we think that should be free to everyone. And we want to drive down those generational stats to as low cost as possible, to the zero, right? And so we are making kind of as part of our thing, our plans, kind of driving the cost in terms of compute costs by using different ways of compute and all that. And we want to kind of work with the community to see if there are other ways to do it. For example, your catalog knows a lot about what's happening on the data side, right? If we can get those signals out and use those, can those be used as a way for kind of having that intelligence to build what stats is actually needed? And so there are aspects of maybe their catalog level, maybe their query engine level, but there is aspects of kind of that intelligence which is currently lacking and which could be standardized in a sense, which will be available to everyone, right? So we want to kind of have the community think in terms of that. Yeah, so we are really excited about this. I know there are a bunch of things we want to talk about in terms of Iceberg risk catalog, stats, and optimization. But this one I wanted to focus on one of the key things, which is really the query performance. So thanks. Any questions? And we have some of our engineers back here, so I can direct the technical questions, some of those to our engineers too as well.
The question that I have is like, so this is more like an additional steps on generating a stats, right? So the default, the compaction procedure, say what Spark provides or the other engines, does it or it's relative to AWS only or not?
So this is nothing, so yeah, so you can generate a stats, right? Puffin stat is the open standard. So you can generate that. You can use the Spark procedure, create and build your own ways of writing Puffin files. Kind of create your own sketch based on your data and write a Puffin file and make sure you populate that, all that, right? So that's something that is, you can do it similar to how you did it for the compaction for the Spark job. From the AWS side, we kind of help in kind of taking the heavy lifting out, right? So for Glue Catalog, for example, we provide the compaction, which takes care of aspects of if there are changes happening on a partition, we look at a partition and say, okay, if there are more than 100 changes, then I will go and compact this particular partition, right? In a similar way, this stats feature is like that, is we look at the changes in the data or by schedule, and we build the Puffin file. So this is something that we provide as a kind of as a value add. It's something that you can build yourself as well.
Follow-up question is like, because the data is neutral in a common place, like there could be several engines that operate and keep updating the data, right? So it means there's some automated process that runs in AWS that constantly keeps updating this Puffin file, or I as a person have to schedule something so that.
Yeah, so this is what we build as a, yeah, so the question was like, does the AWS help in automation? So yeah, the answer is yes. Yeah, so when you have this catalog level property, right? You say, okay, I want to keep this catalog performant. Any new tables get created, we will enroll them, we'll schedule the stat generation for them, and we'll keep them updated, right? So that this automation is what we provide as part of it.
Very good. Any other questions? Yeah.
Is there like any API or trigger to know when the compaction has happened?
Yeah, so so when the compaction happens, right, there's a kind of snapshot gets created, right? And the Glue Catalog has set of APIs that provides a way of you knowing the changes to the data, right? So when the table is updated, table is changed, and all that. So you can look at the events from the Glue Data Catalog perspective in terms of what is changed. Okay. I don't know, Carl, do you want to add anything?
The reason for like asking this question. In your Iceberg table, if you're using Glue catalog to publish events, you're like that. Now, here in a sense, if you compaction, we can submit a bar request. This is something that our team can work on publishing also. Same thing with Puffin file generation as well.
Yeah. So yeah, and we emit the events for example, for the compaction, snapshot retention, or orphan file deletions. Those are some of the optimizers or maintenance activities that we support. Those events are emitted to the CloudWatch logs that you can take a look at. Yeah.
So the reason for asking this is like we use the Glue catalog and other services. For instance, like in Snowflake, we have been using the Glue catalog. So in those cases, we get to know like when the metadata has changed or when the compaction changed. We need to like refresh the other sources or the table in Snowflake. So we just want to know like if is there like any event that has been like emitted so that we can follow that, like refresh the.
Yes, I can follow up and provide you the kind of spec and the APIs on that. Yeah.
Okay, thank you so much.
Okay, there's one more question. Okay, hang on.
So do any other query engines like Trino or Spark, can they use these stats and do they use?
Yeah, so the question was about the Trino and use of the stats. So yeah, the Trino has built-in integration. By default is off, right? So you need to kind of ensure that when you use Trino and you need to enable that, or maybe
The stats, I mean, the Puffin stuff was added by a Trino contributor. They're on by default. If you write through Trino, you automatically get the stats created.
okay, it's on by default, okay?
Yeah, it's a critical part to have good, good results.
Yeah.
And every engine should write them as they're writing them. It shouldn't just be Trino. I don't know if Spark does, but it absolutely should because they're critical to performance.
So it's like, is it always up to date or it's async?
They're collected as part of the writing query, as they should be. I don't know.
Along those lines, should we make the min-max? I think as of now, the manifest says min-max are optional. Is ever it's going to be a required field?
I will, as the founders,
Should they make min-max stats optional? Or I mean required?
required.
Yeah, I mean ideally you
Yes.
would, but.
They're also not the min-max. They are a bound on
Bound.
the outside, and you can't use them to like return faster results. The min is guaranteed to be a value smaller than the minimum value because for like strings, they're often truncated. Making them required might put undue constraints on like streaming engines. It might be really hard. There's lots of problems where it doesn't work, but if you can collect them, you absolutely should.
There's also a lot of challenges with like positional deletes that may invalidate some of those values. So there's, equality deletes, positional deletes. There's so many cases where you can't really trust it to just like grab the max and say, oh, there's the result. You'll probably get it wrong sometime.
To maintain that min-max. Just small comments, like it's maintaining those min-max of the entire table, especially it's a huge, super large, will be expensive. Yeah.
You can reach good performance with approximate numbers. You don't have to present precise.
Exactly. Right.
It's okay to be wrong.
Yeah, the sketches are approximate, yeah.
All right, very good. Thank you, Sandeep.
Thank you so much.